Good morning. Today I will present a review entitled Energetic Costs of Coping with Environmental Contaminants, Metabolic Trade-offs in Fish. Why is this topic important? Increasing pollution in aquatic ecosystems. Fish are highly sensitive bioindicators. Most studies focus on toxicity. Energetic consequences remain understudied. Fish are exposed to a wide variety of pollutants, including heavy metals, pesticides, pharmaceuticals, microplastics, nanoplastics, and other emerging contaminants. These pollutants rarely occur individually in nature and are often present as complex mixtures, creating additional physiological challenges for aquatic organisms. Energy acquired from food is allocated to several vital functions, including maintenance, growth, reproduction, immunity, and behavior. Under normal conditions, fish balance these energy demands efficiently. However, environmental stress can disrupt this balance and force organisms to reallocate this energy resource. The concept of energetic trade-offs suggests that organisms possess limited energy resources. When contaminated increase maintenance and defense costs, less energy remains available for growth, reproduction, and other fitness-related processes. This trade-off represents one of the main mechanisms linking pollution to ecological consequences. Mechanisms increasing energy demand. Exposure to contaminants activates several energy consuming processes. These including detoxification pathways, antioxidant defenses, cellular repair mechanisms, and hemostatic regulation. All these processes require ATP and therefore increase energy consumption. Oxidative stress is considered one of the most important mechanisms of contaminant toxicity. Environmental pollutants stimulate the production of reactive oxygen species which damage proteins, lipids, and DNA. To counteract this damage, first must invest additional energy in antioxidant defense and repair processes. Mitochondria are responsible for ATP production and cellular energy supply. Many contaminants impair mitochondrial function, reducing energy efficiency and increasing oxidative stress. As a result, fish may require more energy to maintain basic physiological function. Effects on growth. Reduced feed efficiency, slower growth rates, lower biomass accumulation. When contaminants increase maintenance costs, energy is diverted away from tissue synthesis and development. Effects on reproduction. Contaminants exposure can reduce reproductive investment by disrupting endocrine pathways and increasing metabolic costs. Reproductive consequences: reduced fecundity, delayed maturation, hormonal disruption, lower reproductive success. Reproduction is one of the most energy-demanding biological processes and is therefore quickly affected by environmental stress. Effects on immune function. Immunological trade-offs: chronic inflammation, increased immune activation, reduced disease resistance. These responses increase energetic demands and can reduce disease resistance in exposed fish population. Behavioral changes are among the most sensitive indicators of contaminants exposure. Behavioral alterations: reduced swimming performance, altered feeding activity, poor predator avoidance, lower ecological performance. In natural environments, fish are usually exposed to mixtures of contaminants rather than individual compounds. Interaction among metals, pesticides, pharmaceuticals, and microplastics may increase physiological stress and energetic demands. Therefore, mixture toxicity is an important area of current research. Ecological implications from individuals to ecosystems. The consequences of energetic trade-offs extend beyond individual organisms. Reduced growth, impaired reproduction, and weakened immunity can ultimately affect population dynamics, species interaction, and ecosystem stability. Those energetic costs provide a critical link between physiological stress and ecological outcomes. In conclusion, environmental contaminants increase metabolic demands and force fish to relocate energy toward survival mechanisms. These energetic trade-offs negatively affect growth, reproduction, immunity, and behavior. Understanding bioenergetic responses will improve ecological risk assessment and enhance our ability to predict the long-term consequences of aquatic pollution. Thank you for your attention.